Welcome back to Nature of Code in Rust and GGEZ. Today we're going to be going over example 1.5, vector magnitude. The magnitude is a fancy way of saying the length of the vector. There's some great explanation of the math behind this. However, the basic idea is we're going to use the Pythagorean theorem, which is this a squared plus b squared equals the c squared, and this is the magnitude. So that's what we're looking for. The square root can take something that's squared and give you, well, the root, what the thing would be. So c squared, the square root of c squared is c. So let's go ahead and implement this in our code. In our basic library, well, let's actually go into our utilities and set up our square root here to begin with. So I'm going to do this in the general impl. And I actually realized when I was thinking about this, we're going to have a little bit of trouble because taking a square root isn't something that we can necessarily do with t here, because it's going to be different depending on if it's a float or if it's an integer. So we're going to have to impl t for vector 2 of t, where t is a num. Also, I don't know if it needs to implement copy. We'll find out. We don't need mul assign, but let's say that it's a float. So it's a num and a float. And that's what we really care about here. So then we're going to have a pub function magnitude. We're going to take in a reference to self, and we're going to return an F32. Actually, we're going to return a T. Sorry about that. And then, okay, so what are we going to do? We're going to get a squared plus b squared. Well, that's self.x times self.x plus self.y times self.y. I might be able to do something with like pow_f here, or pow_i, or we can say pow_i2, like and that's just one way of getting, like, taking y to the power of 2, but this also works. Now we want to take this resulting number and take the square root of it. So I'm just going to wrap this in parentheses and do square root, and that gives me this F32, the square root of it, and that's it. That's our magnitude. So we're going to come back into the main library here, and we're going to do the rest of the code of whatever we need. So we're going to need 2 meshes, one for the line and one for the top bar that we saw. So let's go ahead and have those stored away here. So we're going to have the length mesh. You're going to be an option that holds a mesh. And then we're going to have the line mesh. You're going to be an option that holds a mesh. I don't know what else we necessarily... Oh, a center position. We want the center. So center is going to be a vector 2 with F32s inside. And I think that's everything we need to store inside of here. We'll do the rest in the functions down here. Okay, so we need the 2 meshes. So that our length mesh is equal to none. That our line mesh is equal to none. Okay, so to create center, we actually need to know the width and the height. So let width height equals graphics drawable size. Pass it in the context. We do need, there we go. And then we can get our center. So center is equal to a vector 2 new with width divided by 2, height divided by 2. All right, so now we have everything to build out our main state. We have our length mesh, our line mesh, and our center. Excellent. Okay, so to create those actual meshes that we want to display, we'll do that in update here. So if we want to get the, let's say like that length mesh on the very top, we're going to need to know where the mouse is, where the center is, subtract the mouse from the center, and then get the length of that. And that's a really easy way to like get the distance between two spots, is subtract them from each other and then take the magnitude of it. So we can get our mouse position. So let mouse equals mouse location, pass it in the context, and we'll get this vector 2. And then we already have our center, so we can have maybe the distance. So let distance to mouse is equal to, and this is where we have our mouse minus self.center. So that gives us this vector here. And then if we want the actual distance, so let distance equals distance to mouse. And this is where we get the magnitude. So there we are. This is that distance. Okay, so in order to create that, we need a rectangle. So we're gonna have our length rect is equal to a GGEZ rect. We give it the x, which is going to be in the top left position. So 0, 0 here. Our width is going to be the distance. And our height is, let's just give it 10. And this finally allows us to create the mesh itself. So we're going to say self.length mesh equals a sum, a mesh builder, new, we'll create a rectangle. So the mode for this, we're just going to do a draw mode. We're going to fill it. For the bounds, this is the length rect. And for the color, let's actually create a new color here. Let's let length. I don't necessarily want to have to create this every single time, so let's actually store this up here too. So we're going to have the length color, and you're going to be a type color. Equals color new. Let's make this green. So 0.0, 1.0, 0.0, and the alpha is 1.0. All right, store the length color there. Then you're all fine. We'll then go ahead and build you, pass into context, $u, and we've got, oh, this is going to be self.length color. Okay, so that's our length mesh. Let's go ahead and actually just draw this out, see if we're on the right path here. So we're going to do a if let some mesh is equal to a reference to self.length mesh, and we want to do our graphics draw, passing in the context, the reference to the mesh, and then we want draw params. But in this case, we just want the default ones. We don't actually need to overwrite anything. So then we run this, and let's see if we get our length. There we go. We do indeed. So our mouse, depending upon how close it is to the center, gives our length mesh at the top. We still want that line in the center though. So previously we were using not a translate, but the transform, I believe, to sort of shift the entire canvas around. And I found that we can't really do that here, unfortunately. It ruins the position of the rectangle, and everything I did to try to make that work just didn't work for us. So we're going to need to create a mesh and put it in the exact place that we're expecting. So let's create the points for that first. So let points equals an array. So to begin with, we want the center. So self.center.toArray. That's one set of points, and then we want wherever the mouse is for the other one. Well, we have that right here. So we have mouse.toArray. That gives us these points, and now we can create our mesh. So self.line mesh equals sum. We have a mesh builder, new. We're going to create a line with a reference to points. For width, let's make this 2. And for color, we can just make this white. Question mark u, build u. And there we go. Okay, so that should set us up with the line mesh. And then finally, we want to present this out as well. So if let sum mesh equal to self.line mesh, then we're going to do our graphics draw context, the mesh, and a default draw params. And so if we run u, now we have our line. It's exactly like before. We're just having it go straight from the center to the mouse. We're not using that transform. And we have the bar in the top showing how far away the mouse is from the center. And that is example 1.5, vector magnitude in Rust and GGEZ. I'll see you in the next video. Thanks, and bye.